This is the Algebra 1 Summer School Unit 7 Lesson 2 practice video. Lesson 2 is all about writing exponential models, real life situations of exponentials. On this practice video, I'm going to do number 1, 4, and number 7. If you have questions other than those 3 problems, check out the key that's posted on Canvas or come into office hours and ask your instructor for help. Alright, so number 1, you invest $1,000 in a savings account that earns 7% interest each year. How much is in your savings account after 15 years? Well, we talked in our notes about how when we put money into a savings account that earns interest, that means that your amount is going up. It's going to increase. Because we have 7%, we need to use one of the models that deals with percent change. And since we're increasing, we want the one that's 1 plus p for increasing percent. Now our model setup, the amount of money that's in our savings account, S, equals, now I always put the amount I start with first, so 1,000 times. Now it's percent increase, so it's 1 plus 7%, which is 0.07 to the x. If you want, you can multiply or add together, this 1.07. So I'd have S equals 1,000 times 1.07 to the x. The 1 plus 0.07 and the 1.07 are the same thing. Now I'm going to use that equation to figure out how much money is in my account if I invest $1,000 after 15 years. So I'm going to take the equation and I'm going to put 15 in for x. Once I evaluate that with my calculator, I found out that I'm going to have $2,759.03 in 15 years. All right, looking at number 4. You just got a new to you car for your 16th birthday. When you get the car, it's worth $15,000. It is going to depreciate, which means decrease in value, by 8% every year that you own it. How much is the car worth after 4 years? Well, we already know it's decreasing. When you depreciate, you're going to decrease in value. Our model setup, we're going to say that the worth of the car, so I guess the amount the car is worth, is starting at $15,000 times 1 minus the 8% that it's depreciating by. Now, if I wanted to rewrite that equation, I could say the amount is 15,000 times 0.92 to the x. All right, that 1 minus 0.08 is the same as 0.92. Now, the total after 4 years, well, I just put 4 into the equation. So I'll have the amount is 15,000 times 0.92 to the 4th power. When I do that, I find out that the value of my car 4 years later, so on your 20th birthday, would be $10,000, $10,745.89. So it loses about $5,000 in value. Last problem, flip to the back, it's number 7. The height of an anthill can be modeled by h of t equals 5 times 0.98 to the t, where t is the number of hours since it started raining. Does this model represent growth or decay? Well, the growth rate here, 0.98, is less than 1, so this is exponential decay. What is the rate that you're growing or decaying by? Well, since it's decaying, I have to do 1 minus the percent that's left, which gives me 0.02, which is 2%. So the anthill, when it's raining, is decreasing in height by 2% every hour. How many inches tall is the anthill when it starts raining? Well, that would be the first value, 5 inches. And how tall is the anthill after it's been raining for 5 hours? I'm going to take the height after 5 hours is 5 times 0.98 to the 5. That's my 5 hours. When I evaluate that, it turns out that the anthill is 4.52 inches tall after 5 hours. All right, that's your exponential modeling practice. Next, we're going to be comparing linear and exponential models. We're going to be putting them together. So you need to make sure you're really good at both of them. If you're struggling on either, please come into office hours and ask for some help.